Okay, we're going to look at probably one of the most important concepts in graphing, which is the rectilinear coordinate system. Now, in the rectilinear coordinate system, which was really proposed by Descartes, I think therefore I am philosopher, he created two number lines. A number line of real numbers in one direction and a number line in real numbers in another direction at right angles to each other. Now, Descartes did this so that we could get the quadratic theorem out of it. And what happens is, or not the quadratic theorem, the Pythagorean theorem out of it. By putting a starting point, which is 0 on the number line for x and 0 on the number line for y. Now we usually talk about them in two variables, so this would be called the x-axis, and it has all the values for the x variable on a real number line. And so you go from 0 to 1 to 2 to 3, and then in the negative direction, -1, -2, -3. 1, 2, 3, -1, -2, -3. And so on the x-axis, positive is to the right, positive to the right, negative to the left, like the real number line that we were using in one variable. But then connected another axis where for the y-axis, positive is up and negative values are down. So you get +1, +2, +3, and coming down -1, -2, -3. And what this allows us to do is to represent numbers or equations in two variables graphically. And it creates pairs of numbers. So the origin, the starting point, has 0 for the x value and 0 for the y value. So the origin is this collection of numbers, which we're going to call an ordered pair or a coordinate. And the ordered pair, you do the x value first, then the y value. And what this does first visually is notice how it cuts all of space into 4 distinct sections, and they're going to be quadrants. And so we have quadrant 1 here. Now we go counterclockwise. Quadrant 2 is here, and quadrant 3, and over here quadrant 4. Now all the numbers in quadrant 1 have a positive x value and a positive y value, because positive x goes this way, positive y goes this way. So every pair of numbers in the first quadrant has a positive x and a positive y. In the second quadrant, you have negative x values, as the negative values run across here, and you have positive y values. Quadrant 3, both the y and the x are negative. And in quadrant 4, the x values are positive, and the y values are negative. And so this is how we can divide space to work with a pair of numbers. So to graph anything on our new axes in this, to graph things in a Cartesian plane, we focus on the two values in the coordinate pair. They become a point. So for example, I'll do some points here. We'll look at the point 0, 5. We'll call that point A. And we'll call that point 1. And so I have 0 for the x value. So if I have 0 for the x value, there's my origin, 0, 0. I don't move at all in the x. The x value is 0, but I come up 5 in y. So let me 1, 2, 3, 4, 5. Graph paper makes this a little bit easier. And so point 1 is 0, 5. And notice, that's my y, that's my x, that this is on the y-axis. If you're on the y-axis, your x value is 0. Now I can do point 2. I'll have 5 for my x value and 3 for my y value. So I come over 5. So I move over 5 in my x, 1, 2, 3, 4, 5, and up 3 in my y. And so point 2 is 5, 3. And this is in quadrant 1 because it has a positive x and a positive y. And so notice my motion here. I move 5 in the x and up 3 in the y. 1, 2, 3. And so the thing that Descartes was hiding in using this was this triangle. And the legs of the triangle from the origin is the x value and the y value. So let's look at a couple other points. I can have the point 3, -4, 2. So this says I go negative in the x, 4. This is -4, so 1, 2, 3, 4 in the negative direction and up 2. And so there's point 3, -4, 2. So that's up 2 in the y, back -4 in the x. And so we can define any point in space by this pair of numbers. So let's look at point 4, -6, 0. So I'll come over -6, 1, 2, 3, 4, 5, 6. But 0 in the y, so point 4 is -6, 0. And notice that lies on the x-axis. And so the x-axis, the y values are 0. Because I go neither up or down in the y. And so we can graph any space, any point on a piece of paper with just two values. And so one pair of numbers defines each point exactly. So the point 2, 3, come over 2, 1, 2, up 3, we'll call that point 5, is different than the point 3, 2. So we go 1, 2, 3, 1, 2, that's point 6. So it's not just the numbers, it's the order the number comes in from, with the first one being x and the first one being the y value. Well, what's nice about this is that ordered pairs are a good way of representing an equation. So we can think about if x plus 3y equals -12 as an equation in two variables, we can think about it as a collection of ordered pairs. And so we can think, well, does the ordered pair 0, -4 solve this? And what this is telling me is I can let my variable x equal 0 and my variable y equal -4. So I'll substitute. I'll put in 0 for x and -4 for y, and I want to see if this is true. So 0 plus -12, -12 equals -12. And this ordered pair solves this equation. But it might not be the only solution for the equation. And that's the thing we're going to work towards, is seeing all the possible ordered pairs that can come out of this. Let's check some other, look at checking ordered pairs as a solution. So I could have y equals -5x. And I want to know what the ordered pair was. Let's say if my x value is 5, what is the y value? So I substitute my x value into the x variable, and that tells me y is -25. So an ordered pair solution for this is 5, -25. That's telling me when x is 5, y will be -25. I could also ask, what is the x value when y is 0? So I substitute in to this, I substitute in 0 for y, and I ask myself, what is x? Well, in that case, x is 0, and an ordered pair solution is 0, 0. If we plot all the points that come out of this, so if x is 5, 1, 2, 3, 4, 5, then y is -25. Down here. And if x is 0, y is 0. And what we're going to find is these make a line, and all the ordered pairs we want lie on that line. Everything with any combination we can get in here will come on this line. That's where we're going with this. But our big thing is ordered pairs fill in, variables. And it's those variables that we're looking as our solutions. Let's see here. I got moved over. Let's come back. And we'll explore more what it's like for our equations to cover space. And what this means is that this equation here has infinite possible answers that make this line. If we don't know one of these variables, we get every one of these as a possibility. And that really was the secret that Descartes did from this. He was able to turn an equation into something visual. And we can look at the visual thing and go, well, if I start on this side and I move this way, in my x value, my y values get smaller. And it's that visual clues that Descartes used to encode these things and to make the encodings work. All right, we'll continue exploring ordered pairs and Descartes' graphing technique as we continue.